Hello and welcome to lesson 2 of week 8. In this lesson, we are going to continue with hash tables and we are going to be looking at how we can address collision using open addressing. In the last lesson, we looked at how we implement hash table in Python. We see how we can create different methods to add elements to search or table in Python, and we also learned that we have data structures that already use hashing in Python, like the dictionaries and the sets. We have a default inbuilt method called the hash function in Python that we can use to get a hash code for elements in Python. Now we looked at how to address collision using the chaining technique in the last lesson, and we want to look at open addressing. We have said that there are different variants of open addressing in Python. We have the linear probing, we have the quadratic probing, and we have double hashing. And we're going to create a class in this lesson that will have methods that sorts all of these different variants of open addressing. Now in open addressing, we store conflicting elements in the next available bucket. What it does is that it looks for the next available slot using the probe sequence, and that probe sequence is either linear, quadratic, or double hashing method, and stores that element there when there is collision. Now we know that collision is when we have two keys hashing to the same slot or bucket. Now let's create a class, and we call this class hash table. We're going to create the instance method here in it, and here we want to have the size also. We'll not put a default size, and let's put a method. I'll put a default method to be linear, so we're going to use this so we can illustrate both linear, quadratic probing, and also the double hashing. Now for this init method, I want to define the size, the table, and the method. So I'll say self.size is equal to the size that the user supplies when they create an object of the class. I want to have, this is self. Then I want to have the table to be, we want to have the number of buckets should be equal to the size. So we can say self.table. We can do it like the last lesson, or I want to create a different way for you. So it's equal to, because we are not using chaining here, none times the size. Alright, and then we want to use, now recall when we did the hash, we modulo the size and we created a table to have a list of empty tables that is equal to the size. And here we use a different method to just have a list of empty buckets that is the number of size of that object when it's created. And then now we want the method to be what the user supplies or the default method, but let's convert it to lower, so we'll use method.lower like this, so it has to be in lowercase. Now let's define the hash function. So let me call this hash function. So it's going to be similar to what we did for the chaining. So we want to hash the key, right? So we want this to be like, let me put a comment here and say this is the primary hash function so you can understand this. So we have this hash function, and better syntax to use 3 quotes like this for comments within a method. So we have this, and then we want to return the hash of the key modulo self.size. So this, we are not making this a private method, so we don't have the underscore in front of it like we did in the last lesson. Now we want to create the second hash, and this one we want to use like a secondary hash function that will use the second type of probing, which is the double hashing. So let's say let's call this second hash. So we'll just create all the methods within here, and then when you instantiate, you choose what method you want to use. So cell key, and here we want to say, let me leave a comment here so you can understand that this is a secondary hash function used in double hashing. So what we want to do here is to return, because what we said in open addressing is that it looks for the bucket next to where it has the conflict, next to the bucket with the conflict, and we want to make sure that we use a modulo for it to stay within the index, to be within the size of the bucket, right? So what we'll return now is we are going to the next available bucket, so 1 plus. Now we are going to hash the key modulo self.size. Now we're going to say size minus 1, and so you don't want to have any index that is out of range. So we are saying this self.size minus 1 is by itself before this, so it's going to look at the size of the bucket minus 1, and then it's going to add 1 to the hash key. So this, what we are doing now for the double hashing, is that you're hashing twice. You are trying to make sure that this solves collision if you want to use the double hashing method. So if we want to have like the next index method based on the probing method, like linear, quadratic, double, right, we can create methods for those ones. So what we did here, we have a primary hash function and we have a secondary hash function we just call second hash. So all of this method is not necessary you have all in your code. I just want to make sure we illustrate the different open addressing variants that we can implement in Python. Let's call this other one probe. So let's use the linear probing, quadratic probing in this. And so let's say in this probe you get the key, and also let's put a variable called I. Now I that we have here will determine the next index based on a probing method, and we want to address the linear, the quadratic, and the double hashing probing method in this probe. So let's get a base hash. So the base hash now will be equal to self dot. So base hash now, because this is the primary hash function, let's call the hash function and hash the key. So we'll say self dot hash function. Now the next thing we want to think of is to maybe use a conditional statement to say if the method is linear, we want to return a linear hashing method. If the method is quadratic, we want to return. If it is double, we want to return something different, so that we can handle it here instead of having 3 different methods for each one and then you choose what method to call. So we'll say if self.method is equal to linear. So now you see that we made it string to lower here just so that we'll make sure that it gets this here. So if self.method is linear, we want to return so we use the base hash function that we created here plus the I here. So base hash plus I modulo self.size, right? Now we'll say if, so we'll use elif. So say if the method is equal to, now we want to check if it's quadratic method that the user supplies. So we'll say if the method is quadratic, we want to return. Now for quadratic, you want to say the I raised to the power of 2. So quadratic is like you are doing exponentiation, right? So we'll say we return base hash plus, so now this I double asterisk 2 like that. So let's say base hash plus I double asterisk 2 like this, and then we'll modulo the size. So we always do this so that the index will be within the range or size of the table. Now if the method is double, so let's say elif self.method. So we want to get a condition where the method is not specified and we'll tell the user to supply a method, right? So we'll use that in the else condition. So now say now if the method is equal to double, now you can see that we use the second hash here for double. We created that second hash function here, so we can just easily call it here to use it for double. So now if it is equal to double, what we'll return is we want a double hash now. So we'll say base hash plus I times self dot the second hash now. Second hash, so second hash the key, now modulo self dot size. Always modulo by the size. Alright. Else we want to raise, maybe we'll raise error. So let's say raise value error, and the value error will raise is invalid probing method, let's say. And when we tell the user that the probing method is invalid, maybe we'll say use linear, quadratic, or double. Okay, so we can have a custom like this. So now we have find this probe that we'll use for a hashing method. So you can see how we did the different variants within just one method here, and we use conditional statements to see when the user supplies a hashing method. Now the next thing we want to do now is to see how we can insert, how we can search. So let's create a method for insertion of elements into this bucket. So we'll say def insert. So let's say insert element, right? And here we'll provide the key and the value. So let's say self key value. So I want to make this a little different from when we did the first one. You can also have just self and value, and then you do the hash to get the key within the function. But let me do it a different way, since the other way can be done based on the last lesson's method. Insert. Let's say insert key value pairs using selected probing strategy. All right. Now here we want to say I now is going to be index, right? The index is going to be the range of the size that is specified for the table. So we can now say for I in the range self.size, we want to say the index is equal to self. So now we're going to use probe method, because now we'll decide what method is supplied, and the probe will decide to use what will be returned based on what we select when we create an object of this class. So we'll say self.probe will pass the key and I. All right. Now we have the index. So if self.table, so if the index is none, so if there's no element in this particular index here, if it's none, or if it has if the bucket already has an existing item that has the same key, then we want to do something. So if self.table.index, so let's say self.table index like this, the first position is index position 0. So if that position already have the same key, so we're trying to address collision now. So if that key already exists in that bucket, we want to insert the key value in the table index. So we'll say if it is none, if there's no item there, or if an item already exists within it, we want to say self.table index is equal to, we want to put the key and the value. So I'm using a different method of doing this, but you'll see that when you practice this, you can do it differently. Just get the basic idea. So what I'm saying here is check the bucket. If it's empty or it already has something in it, you want to insert the key and the value beside it. So this method is just like when we have a dictionary in Python. Normally all keys are unique, but in the event that we have this collision, which means that it's hashed to the same key, we want to make space in the next bucket that we will use to store this. Now this probe function that we created here, when we specify the method as linear, it hashes this like this. If we provide as quadratic, it hashes like this. If we provide the method as double, it hashes like this. And so when we use this open addressing, we don't have that collision problem because it just looks for the next available bucket next to the conflict, right? And then we'll do return here, and then let's raise an exception if that is not the case, to say the hash table is full, right? We'll say raise exception, and we'll just put this exception here, hash table is full, something like this. Now this method should insert if all goes well. We're going to test it, but let's create a method that will search, that will delete, and then that will display. So let's say def search, we get self. Now for the search method, we want to get the key, we'll pass it through the probe method, and then we will return the found index or the found element. So we'll say for I in range, and this is going to be the size. So for I in range self.size, we want to get the index will be equal to, we use the probe function self.probe. So we use that probe method and we'll specify the key and I, and then we'll say if self.table, so if the table, if that bucket doesn't have an item, so if self.table index, let's say if the element there is none, so if it's an empty bucket, we want to return none, right? So but if it has, we want to return the elements there. So we'll say if self.table, and let's put the index. So there's another way you can think about this and do this. So if the first index of that bucket already has an item and the item is the key, you want to return the item. So we'll say self.table index and 1. So because index position 0 is the key, index position 1 is the value. So we always know that indexing starts at 0. So in a bucket is a list that has index position 0, 1, because here what we appended in the table is the key and the value. So 0 will always be key, 1 will always be value. So when we use 0 here is when you get to that bucket here. So the bucket is at this index position, and you look at the first element in that bucket, which is the key, and it matches the key that we are searching for. You want to return the value, which is at index position 1. And if it is not, we'll just return none. Okay, so let's create another method for delete. Let's say def delete, let's say self key, and we want to check for the elements, and then we want to delete the element. So we'll say for I in range self.size, the index is equal to let's use the probe key I, right? So index is equal to probe key I, and we want to now search the table using the index. So we'll say if self.table index is none, we want to just return false. So it's not found if it's none, right? So we will return false. But if it is found, so let's say if self.table index, the key is at index position 0, is equal to the key, we want to delete it. So we'll say let's print something. Let's say we'll print something here, and we'll just say deleting key from index, something like that. So let's use the format string like this, and we'll say deleting key, and here let's put the key name from index name. So let's put index here. So I quoted them so that it will be quoted in the printout, something like this. So to say we're deleting this key from this index, something like that to print out. Then let's say self.table index, and we'll set it to none because we have deleted what is there. So now it's none, and then you return true. And if all of this fails, just at the end just return false. So something like this. Okay? I think this return statement here should be here. I think so. Yeah, so return false. Now we want to check another condition, or we want to create another method that maybe let's call this a display method, where we want to just display everything in the table. Let's do a method that will just format what we display, so we can have a nice formatting to see how it looks like. So let's say dev display like this, and I'm going to use a print statement here. I'll say print, let's make it start from a new line, so we'll do \n, and I'll put index, and I'll put a tilde sign. I just want to format it to say like a table, key value like this, something like this, just to have a format. Then I want to print like a line, so I'm putting the header then the line. So I'm just formatting. This has nothing to do with coding, it's just how you want to format your stuff. So let me use dashes to print the line. I want it to be the same length with this. Then now I want to now loop through the key value pairs. We have an inbuilt function in Python, the enumerate function, that returns the index and the value. So that will be the best to use. So I'll say for I item in enumerate like this, and I'll self.table, so we can return the key and value. We want to say if the item, so if the item exists, all right. So for I item in this, if it's not an empty bucket, let's use the format string to print out like the key and then the value, but we want it to maybe align it, like we want to format the alignment. This is not necessary, I'm just telling you what this code I'm about to write means. If I put a curly brace and I put the I, which is going to be like the index now, and let me format this to center, use the caret sign to format, to just shift to within that row, I just want to center it, maybe 5 shifts, something like this. That's what I'm doing with this code. And it's just because I want to format it to be a table, and then I'll still use the same pipe. I'll get the item, and this is going to be at index position 0, which is going to be the key, and then I'll do the value, which is index position 1, so to be item 1 like this. So we have the heading here, and then we have this coming down there. So we can say else if the bucket is empty, we'll just print, let's say just dashes and empty bucket. So we'll say print, and I'll format this again to have the same formatting to center this. To say here will be I want to center this with maybe 5 shifts like this, the same way, space, pipe, space, let's put 3 dashes like that, space, and the same thing, something like this. So we're just formatting the display. So all of this is just to loop through the key value pairs and display it in a table. So I just printed in tabular form, so it will print out as table. Let's test this so far and make sure this is working before we go further. So we'll say if name equal to main, we want to now say let's have a nice printout. So I'm printing out here, let me have a heading, linear probing. So I'll try linear probing first. So this is just the heading, and then let's create an object of the class, and I'll say linear ht is what I'll create it, is what I'll call it, and then I'll instantiate the class hash table. I'll provide the size of the table. Let's say I want 7, and I want the method to be, I'll say method is equal to linear like this. Now it's time to loop through. I'll say for k v in pair of square brackets, and now I want to have some items. Let's say I have the key here to be apple, and I have the frequency of this apple to be 10. Then I have the next item here, I have a tuple here, I have banana as the key, and let's say I have a value 20. Then I have grape, let's say grape is the key, and I have the value here 30, and let's say I have orange. So each of these is its own tuple. So let me put it like this, orange, and orange is, let's say we have 40 oranges. Let me just put orange 40. Now I want this to be the list. We can create this as the elements outside of here, so we can always use it instead of doing it in the statement, but let's do it this way. So I want to loop through key value in this. I want to say linear, the name of the object. Now I want to use the insert element method, so dot insert element, and we want to insert kv, and then let's display it after we've inserted this item, key and value, and let's say linear ht dot, we have the display method created, and we want it to display everything that is there. Alright, so let's do for linear probing and see if it works. So we have it formatted like we wanted, the index position 0, 1, 2, 3, 4, 5, 6, because we have 7 size, right? So 0 to 6 is 7, and you can format further if you see this formatting is not like really aligned like we want it. But we have index, key, value, you know what the headings are, and as index position 0 is empty, you put dash, index position 1, apple is stored there, we have the key apple, the value 10, key banana, value 20, key grape, value 30, then it puts the dash because this index position 4 has nothing, 5 has orange, 6 has nothing. So you see an example of linear probing. Let's copy the same thing, and let's say we want to use quadratic method here, and I'll change this to quadratic. So let's say this quadratic probing, we leave it as still 7, but we put the method. Now we'll say for kb in the same apple, banana, grape, orange, we want to say let me change this variable name to quadratic. I'll say quadratic ht, so I'll say quadratic dot insert element, okay, dot insert element kv, and I will use quadratic dot display here. So this, and before we go further, let's just do the last one, which is the double hashing one time, and here I'll put double ht as the name, method here is going to be double. Now we have the same items. I'll call here double and I'll call here double. Alright, so now I'll clear here, we'll run and we can compare the three. So when I run this, we have the first one, linear probing, we see how it is stored. The second one, quadratic probing, we see how things are stored. And the last one we have here is double hashing, see how they are stored. We see that in different positions there. But we have seen that chaining here, if they hash to the same position, it is just going to look for the next available one based on how we created our function. So these are the different variants in Python for the open addressing method of solving collision problem. Now the time complexity for insert operation in the worst case is big O of n, for both insert, search, delete. In the average case is big O of 1. And now you might now begin to wonder, what kind of real world applications can we use hash table for? It's already used to implement dictionaries in Python. When you want to use a hash and memorization, like this recently used cache, things like that, hash tables are important. If you want to have symbol tables in maybe compiler, hash tables are good. Indexing of your database, counting frequencies of elements, hash tables are important in these operations. In the next lesson, we are going to look at how we can implement hash sets in Python. Thank you and see you in the next lesson.